Okay. Now, the question, of course, ultimately concerns M6-6, where the matrices have 36 elements, 6 rows of 6. You know, you could write a basis for the 6 by 6. Take a few minutes, because you have a lot of numbers to write in each matrix, and you'd have a lot of matrices. You'd end up writing 1440? No, that's not right. 1728, that's not, what's 36? 1296. You'd end up writing 1296 numbers. Okay, they'd all be zeros and ones, and you'd have a few brackets and commas, but it would take you a few minutes to do that. I'd say it would take maybe 5–10 minutes if you write fast. Okay, so you don't really want to do it. You'd want to find a shorter way to indicate those matrices and still prove that you have 36 matrices in your basis and that it is a basis. The easiest way to do this is by mathematical induction. Okay, and I would love to get off into mathematical induction, but I have other things that need to be done tonight, and you know, before people take their finals. And then, you know, can you list a basis for the 6 by 6 symmetric matrices? You might have a little bit of shorthand in the way you write them down, but can you see what those matrices would be? And then can you find a shorter way to reason out how many of them there are? You could always list them. Okay, there aren't as many as there are of these, but it'd still take you, you know, at least 5 minutes to write them down, and that would be perfectly valid. You'd have to argue, analogous to what we have here, that you do have a basis and that they aren't linearly independent. Well, that you have a span and they're linearly independent. It wouldn't be too difficult to write down the general form of a 6 by 6 matrix. You might work from that. So those are just suggestions as to how you might approach this. Mathematical induction, I think, would be fairly tricky on this one for someone who hasn't done a lot of induction, and I assume most people haven't.